Hey people, this is Avoided, and in this video I'm going to be showcasing a way of delivering items in Oxygen Not Included using the shipping system, but without leaving items on the rail. So when using the shipping system that the game includes, there is a caveat that items queue up on the rail when the receptacles are full. So if a duplicant fetches an item from the receptacle, then every item will move one spot along, and the receptacle will refill, but if there's an excess of items, then they will queue up on the rail. And this is a problem when it comes to storing food. So what will happen is that food on the rail will rot. And there is a workaround to this problem, which is to cover the rail with tiles, but that's not always practical. So as an alternative to doing that, I have invented a better, or rather a more exciting solution to the problem, which I'm going to be showing to you guys. So to get started, I'm just going to show the system in operation. So a brief explanation of what we have. There is what I would describe as a pantry or a storeroom area on the left, in which we have two different types of items being stored, potentially two different foods. And then there are three consumer sort of areas on the right. So this might be a kitchen where you're cooking food, or if it was cooked food being stored here, this might be a lounge where you're eating the food, or it might be, for example, if you have a recreation room and you need to deliver something like meal lice or bristleberries to it, then this might be that room. So another thing is that this system can be daisy chained, so you can add additional storage areas in a modular way to the sort of bus of food or items, and the items are multiplexed, which means that one mechanism of transporting them is used for different kinds of items, and sorting is used to differentiate between them. However, each logical block can only deal with one item type. So for example, this is going to be delivering only, in this example, dirt, and in this example, sand on the right. Okay, so let's break it down step by step. So the first thing that happens when we ask for extra resources is that we no longer output green from the bin, which means that it's not full, and we just not that because what we want the line to represent is I want more resources. Little sidebar, this design relies on the fact that the ribbon is essentially what I would call high impedance by default, or phrased another way, if two writers write to the ribbon and one of them writes red and one of them writes green, then the winning color is green. And so when we have multiple writers, we're actually implicitly ORing them together, because if any of them goes green, then the output goes green. So how that works is we just take all of the outputs from the fridges, and for example these two, the depot number 1 and depot number 3, both require dirt, and you can see that the writers both write to the top line on the ribbon. So if either of them output red from the fridge, representing I need new resources, going through the NOT gate, turning into green on the bus, representing I need new resources, then the output will be green, and the module will learn that some receiver on the bus would like that resource. Then what happens as well is that we open the filter. In this case, we're using the new shipping filters that are released in the most recent update as of this video, and we turn on the filter, which means that the filter essentially, when the automation turns on and off, it just makes the filter act as if there was a shut-off valve on the rail. So we turn on the filter, which means we do want to have resources travel down this path, and then we filter out the resource that we're looking for. We send all other resources along the bus. So the two things that have happened so far is that we've notified the shipping system that we would like resources sent to us, and we've also selected on the bus that we would like to actually retrieve the items that are sent. So then what happens in the shipping center is a timing based system. So we're going to have to simulate the game hopefully slowly now, and then we'll see step by step what happens. So the first thing that happens is that the right hand side reader, which is bit 1 in this case, which represents one of our consumers would like resources, goes green. That is mixed into an AND gate, and that AND gate is mixed into a buffer. The buffer is the last thing before the before the conveyor loader, and essentially allows the conveyor loader to go green and keeps it green for a short while. The length of the buffer dictates how many packets we send in each shipment. So if we keep the buffer green for a longer time, the conveyor loader will send more packets in a shipment. So let's unpause. We can see here the the auto sweeper putting items in the conveyor loader and the shipment starting. At this point, what happens is that we read that the shipment has started using a conveyor rail element sensor, and basically what we do is we flip an internal state that represents we have sent a shipment. And I just want to cover a few small caveats here. The sensor is needed because it might be that this depot is empty, and we don't want to toggle into the state of we have already sent a shipment, please wait for it to be received, if we haven't actually sent a shipment. So the rail sensor just determines that an item was actually sent. Then there's one memory toggle here, and this is the important memory toggle to understand. So this memory toggle goes green when there is a shipment on the rail from this depot. And so it goes green, it gets set from the element sensor. At that point, the shipment travels along the rail, and you can see that the memory toggle is still green. When the shipment goes through the filter and into the depot into the requester that asked for that shipment, the other bit on the bus is used. So that bit represents I'm currently receiving a shipment. And so I'm going to try and draw a graph using the automation wire. How it works is that we have a low signal representing I have not received a shipment, then a high signal representing I have received a shipment, and that high signal stays high for the entire time that we're busy processing the shipment. So that might include unpacking it or any other task that we want to do before we determine whether we need more or not. At which point we send a low signal again, representing I've finished receiving the shipment. This is called a falling edge, and the falling edge is what we use to determine whether or not we should send a second shipment. So we have basically got two lines. The first one is I would like resources, and it's expected that that line toggles to low when we don't need resources anymore, before the falling edge of the line which is I have received the shipment. So let's see that in action. I'm just going to clean this up. Maybe I should use a different tool to visualize the graph. Okay, cool. So we can see both lines are green now because this unit is busy processing the shipment. And then what will happen is once the shipment is finished processing, it will go red again. That represents I am finished processing that shipment. If you wanted to, you could add a buffer here to give yourself more time to determine whether or not you need more resources. There is also a buffer inside the sending unit, or I should really come up with a consistent name for these things. The sender has an internal buffer as well, and between the two of them you can basically determine a rule for how long you wait before assessing whether to send more resources or not. In my case, I opted to put the timing logic in the sender because the receivers were all identical, and so it takes an equal amount of time for each one of them to unpack, and so we could reduce the complexity of the receiving side because this is the side that would ideally be inside your colony, and therefore we don't want more gates and logic because it just is less aesthetic. So what happens now is that the other bit on the bus went green during the time in which the receiver was processing our shipment and has now fallen to red again. We go through this OR gate that has a switch. That switch is used to avoid race conditions when you've changed what is on the bus by hand. So for example, if there was a broken segment of rail and you had a duplicate come over and delete it or fix the bus or something like that, there's essentially a state that we can get into where we've sent a shipment but it was never received, and so the system gets stuck. And so the OR gate is just to clear up that race condition, and you can manually toggle the switch in order to say shipment was received. If a requester wants more resources, please send them. So that's what this OR gate is for. And then there's just the last part to understand is the bottom left here. So what this is a time-delayed edge detecting circuit. So let's explain that piece by piece. So in oxygen not included, if you have a series of NOT gates and the input toggles to one of the NOT gates, there is a delay between the input and the output. So if I was to take a switch and play the game on slow, if I toggle the switch, we can see, maybe you can't actually see, but if I was to set a very large number of these up, we would very clearly see that there is a delay. So this one flips, and only when it's finished flipping does the second one flip, etc. And so one way of determining whether or not a signal has changed is by adding a NOT gate to an AND gate. And so what happens now is that when we toggle the system, let's say on, then the output of the OR gate is on. Sorry, the first output becomes on, which is our switch, but the output of the NOT gate is off, and so the output of the AND gate is off. And when we flick the switch, briefly this side will be off, and this side won't yet have switched because there's a delay in the NOT gate. and there's no delay in the AND gate, and so briefly while they're the same color on the left, or the same output, the output will go green. And so what we will have is what's called in this case, a falling edge detecting circuit. So you can see that when I flip between this, the output briefly flashes green. Sorry, in this case it's a rising edge. So hopefully you guys can see it. As it turns on, the output flashes green for a moment, which is just on the what would be the rising edge of the signal. So at this point it goes green for 1 tick. Okay, cool. So if we wanted a falling edge detector, all we need to do is just not this. So we just take exactly the same thing, but instead of inputting it directly into the first NOT gate, we just take the output of the... Ooh, hang on. Apologies. We take the output of the switch and we put it through a NOT gate. And so this over here is the same unit that I have over here. So this is a falling edge detector. And one more thing that we wanted to add was the buffer, which is just allows the, in this case, the resource requester to process the resources before we decide that we should assess whether or not to resend an item. So we have the buffer, and so now what we have is a system that upon a falling edge, the buffer delay travels. The buffer simulates its delay, and at that point we briefly flash green, and that resets the internal state, which means we have received a shipment. So what we basically have is a system whereby if you put output number 1 green, that means I would like resources unless you're already sending me resources, and output number 2 green means I have received those resources, please reassess output number 1, and if it's still green, send me more. And so this is infinitely scalable, so you could, well, within the bounds of memory, we could add more and more of these receiving modules along this bus, and also using the new automation ribbon, we could have at least 2 different types of material per automation bus, and using sorters, we can have infinitely many types of material per per conveyor rail. So let's try a few examples and see one more time how the system works. So in this case, let's ask for 2 resources at the same time. So let's say we would like 800 kilograms of sand over here, and we would also like 1,000 kilograms of dirt over here. So now we can see that the 2 timers are busy simulating. This timer over here, meaning please give this guy time, the first receiver time, to determine whether it really wants more dirt. So once the time is finished, we're going to say yes, send it more dirt. We've decided. I've set the values differently for the sand, so it's shipped slightly before the dirt. So I'll speed up the simulation. So now what's going to happen is each of these 2 materials is going to be switched off the rail at their respective sort of sites. So one of them made it through and the other one got the dirt went to our first receiver. The sand is now arriving at our second receiver. At the same time, this new shipment of dirt was sent, and now that this one is reset, a new shipment of sand is being sent. And so basically this is the entire system. There is one more caveat, which is if there's ever a miscommunication between the states of the depots and the receivers, and basically what happens is we send a shipment that's rejected. So maybe that might happen if hypothetically we didn't turn off manual use on a receiver and a duplicate manually made a delivery, which then closed the switch saying we're now full, we don't need this anymore. We send it to essentially a return to sender inbox. So this could be a loop back to the start, or we could just deliver it. In my case, I've made essentially at the end of the line. I'm dumping it, and I'm also using conveyor rail sensors to notify me, a human, that something went wrong. Normally this indicates that the system needs to be tweaked. So yeah, let's just let it reach a stable state, and then I think that's going to wrap up the video. So just to reiterate, the goal of this was to basically allow, for example, a pantry and a kitchen to be separated physically, and to allow a great number of food items to be stored in the pantry without having them queue up along the rail on the way to the kitchen. Cool, I hope you enjoyed the video. Let me know in the comments if there's anything you would like me to change about the presentation style, and I'll have more creations for you soon.